Okay, so we are doing Module 2, Topic 1, Lesson 3. We're skipping the getting started, so you're going to go straight to page 233. So what we're going to talk about here is duplicating an angle. So what I want you to notice, you're going to need your compass today, and you're going to need some patty paper. So whoever's in charge of the video, go ahead and pass out patty paper to everybody, and then start it back up when you're ready. Go ahead and pause. Okay, so you need to pull out your compass, and it's showing you how to duplicate an angle. So what I want you to notice is they are, hold on a second, let me get the right color. Okay, they are going to duplicate this angle right here. So the first thing that you have to do is you have to draw a line. So you're just drawing, it's just a starter line. You're going to construct off that line. Once you do that, what you should notice is they stabbed A, and they found whatever radius, doesn't matter what you did, and then they marked this arc. When they marked that arc, they went over to your line, which they labeled C, they stabbed C and did that arc, which is the exact same length as the other one. Okay, the next thing they did is they labeled these B and D, and they found the length from B to D. They came over here to this point here and marked off B to D, which is right here. And the last thing you need to do is just connect C to F, and you're done. Okay, so now you're going to try it. So first thing you need to do is you need to make yourself a construction line. So make a construction line, and that's what you're going to put this angle onto here using those steps. So go ahead and pause and give it a go, and let's see how you did. Just make sure you have the same marks as me. Okay, first thing I did is I stabbed B. I found out I did a length from B to A and did that arc. I came over, stabbed D and did that arc. Then I measured from A to C. I came over and stabbed E and marked off there, and then just drew my line. All right, let's move on to the next page. Okay, so now it says construct an angle that is twice the measure of A. So when you do this one, all you have to do is first get your construction line. Okay, we'll mark this D, and then put your one angle. So once you construct your first angle, go there and do another one. So the most important thing here is that you've got to make your arc, whatever your arc is. So if we do A to C, this arc here, make sure when you do it here, you make it long enough so that you can put two of those angles on there. All right, give it a go. Should look something like this. So it says, how is duplicating an angle similar to duplicating a line segment? Because you do it twice. Just like when you duplicated a line segment. Okay, we're not doing number 4, so go ahead and skip that and move on to the next activity. Okay, activity 2. So we're going to construct an inscribed hexagon. So what I want you to do is I want you to go through and I want you to follow these directions. So we've practiced following directions. Go ahead and pause and let's see if you can get this correct. Go ahead and pause. All right, so what you should have done is you should have copied the radius of circle A, so go from here to here, copy that onto your compass, and then you mark it off on each section and just go all the way around. When you go all the way around and connect them, what that makes is it makes a hexagon. Okay, so now you need to get your highlighters. Pull out your highlighter, and I want you to highlight an inscribed polygon is a polygon drawn inside another polygon or a circle in which the vertices of the interior angle lie on the outer figure. So now it says, how can you copy an angle to verify that the inscribed hexagon is a regular hexagon? Shoot, just grab some patty paper. So on your patty paper, just copy one of these angles. So maybe like copy this angle right here. Copy that onto your patty paper and just take it around and make sure it maps. Now, the next thing it says, what do you know about the measures of the interior angles of a regular hexagon? You can grab yourself a protractor and measure that angle, and if you do, you should get something around 120 degrees. Okay, now we're going to talk about constructing an inscribed square. So if you look, honestly, to construct an inside square, all you have to do is do a line and do a perpendicular bisector to that line. And we know how to construct perpendicular bisectors. So if I drew this line, that means I would stab, arc, arc, stab, arc, arc, and then draw your line. There you go. There's a um, there's a square because or there that's going to give you your right triangle, and then all you have to do is just connect all these pieces, and that gives you a square. We did that last class. Okay, now it says circle B contains the right triangles. With points A and C on the circle and point B on the center. Describe each element using a term associated with the circle. So I want to give you just like a couple minutes. Go ahead and describe what each of those are. Use your geometry language. Okay, so angle B is a, oops, let me get my pen, is a central angle. BC and BA, BC and BA are both radii. And then AC is a chord. Okay, so now use patty paper to rotate the right triangle to create a square. So honestly, you could grab your patty paper and you could just put this angle right here and then rotate it around and copy it, and that'll give you a square too. Okay, let's go to the next section. So the next section, it says, which congruence theorem can you use to verify that all the sides of the figure are congruent? So if you think about a congruence theorem, which congruence theorem do you think you could use? Well, we've got a side, and we've got an angle. So side, angle, side. Okay, so now it says you can also verify that all the sides of the figure have equal measures by using the Pythagorean theorem, that famous thing that you know so much about because you've done it 50 million times. So here it tells you that BC is a length of x. If that's x, this side is x. So if I go a squared plus b squared equals c squared, x squared plus x squared is 2x squared equals c squared. And then we want to get it out of this square, so square root. So we have the square root of 2x squared, which is the same as x square root of 2. So each side is x square root of 2. Remember that if x squared is inside of a square root, it undoes it and it gets to come out. It says verify that each interior angle measured of the square is a right angle. We're not going to worry about that, so just skip that. And let's go over here to 6. And it says describe each line segment in terms of the circle and in terms of the square. So we're looking at AD and CE. AD and CE. Those both are called diameters. Describe the relationship between AD and CE. So, what do you think is the relationship? Go ahead and pause and write it down. Okay, hopefully you said that they are perpendicular and that they bisect each other. Okay, use diagonals to construct the square inscribed in circle O. Well, if you remember, we looked at the properties of the diagonals of a square, and the properties of the diagonals of a square is that they are perpendicular to each other. So here's a diagonal, connect your dots, or your endpoints. There you go. There's a square. Okay, now you're going to get your highlighter, and we're going to highlight when a ray is drawn through the vertex of an angle and divides the angle into two angles of equal measure or two congruent angles. This is called an angle bisector. Remember, bisector means cutting it in half. So what I want you to do is I want you on your patty paper to go ahead and draw an angle. You can draw this angle. And then fold the patio paper over so you're mapping one side onto the other side. When you open it up, what you'll see is that crease is actually the angle bisector. You've cut it in half, you've bisected it. Angela states that as long as the crease goes through the vertex, it is an angle bisector. Is she correct? So everybody take a pause for a second, thumbs up or thumbs down. Okay, so let's take a look at this. So if we fold it in half, let's say I have my piece of paper, and here is my angle, and I fold it right there. Is that an angle bisector? No, that's not an angle bisector, so no, she's wrong. All right, let's move on. Okay, the last piece is just talking about how to construct an angle bisector. So what you do is you stab C, okay, and then you draw an arc. I don't care what the arc is, whatever length you want. So here is their arc. Once you do that, where it intersects the two sides of the angle, you keep the exact same length, stab, do an arc, stab, do an arc. Then take from your vertex through those two intersection points and you're done. So I want you to go ahead and pause and give it a go on this next one. When you are done, go ahead and restart. Okay, you should have something similar to this. Make sure that you have the correct arcs. It says construct an angle that is 1/4 the measure of h. So if you think about it, if I want to do one that's 1/4 of this, all I need to do is I need to first do half of this triangle, or this angle, excuse me. So here is half, and then I'm going to do half of that one. And when I do that, this angle right here is 1/4. Okay, we are done. Therefore, you are ready to take an exit ticket. You will need your compass.